Alright, so before we get started with today, I'm going to just review what exactly mass is. So, we've talked about atomic mass before. Atomic mass is the mass of one atom, right? And it is measured in atomic mass units, AMU. Where can I locate these atomic mass units? The periodic table, right? The atomic mass unit is the average atomic mass, so usually it's a pretty big decimal. So like oxygen is 15.9994. Again, we just pull them straight off the periodic table. But can I take an atom of oxygen into the lab and find a scale that is an AMU? No. So is that really very applicable to us? No. So what we have came up with is we've actually came up with something called the molar mass. And if you notice, its mass is in grams. Can I take something into the lab and figure out its mass in grams? Yes. So this one is a lot more useful to us. Well, luckily for us, the average atomic mass and the molar mass are the same number. The only thing that's different is the unit. So one atom of oxygen has an atomic mass of 16. 1 mole of oxygen has a mass of 16 grams. So the number is the same. We pull them straight off of the periodic table. And what I would like for you to do in this room, when we're doing molar mass, which you're going to learn how to do in just a second, I want you to round the molar masses from the periodic table to 2 decimal places. So like for instance, hydrogen is 1.00794. I want you to round it keeping these 2 spots. So what is the molar mass of hydrogen? 1.01, right? And why? That just it's going to make your answers more accurate. I just want you guys to get in the habit of always using 2. Okay? All right, so, but do you think I'm going to give you one atom very often? No, because do things exist as one atom a whole lot of the time? No. We have ionic compounds, we have covalent compounds, we have polyatomic ions, we have ions, we have diatomic molecules, right? Very few of those exist all by themselves. So we need to figure out how to find the molar mass of a compound and a molecule, because those are not listed in the periodic table. We have to do a little tiny bit of really easy math. So all we have to do is look at our compound. So in my example, we are talking about SO3. How many sulfurs does SO3 have? 1. How many oxygens does SO3 have? 3. So down here in my equation, if you notice, I took the mass of 1 sulfur, but I'm actually multiplying my oxygen by 3, correct? Okay, why am I multiplying my oxygen by 3? Because I have 3 of them. So basically, this compound is made out of 4 atoms. So you have to find its molar mass. You have to know the mass of each atom. And then all we do is add them up. So the molar mass of SO3 is 80.1 grams per mole. Just like when you're driving, if you're going 60 miles per hour, in 1 hour you have gone 60 miles, right? This is 80.1 grams per mole. So if you have 1 mole, you're going to have 80 grams, right? Okay, the importance of this is, can I go in there and put 80 grams on the scale? Yes. Can I go in there and count out 6.02 times 10 to the 23rd atoms? No. But if I go in there and put 80 grams on my scale, I'm going to have 6.02 times 10 to the 23rd molecules. You guys see that? We can't count out that many molecules, but we can weigh 80 grams. So just like yesterday when I was talking about the remote in the box, we couldn't physically count the remotes. We couldn't physically find one of their masses, but we could go about it in a roundabout way. That's what we're doing right here. Okay. All right, so let's do an example. So we need to find the molar mass of hydrogen peroxide. Does everyone know what hydrogen peroxide is? What is it? It's what you use to put on your cuts. Stings a little bit. Sometimes it bubbles a little bit, right? So, can I take a bottle of hydrogen peroxide into the lab and count out 6.02 times 10 to the 23rd atoms of it? No. Why, right? Does everyone understand how many atoms that is? That is 602, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18. 19, 20, 21. That's how many atoms we would have to count out. I don't know about you guys, but that would take forever, right? Plus, we can't see them. So, we can't go in there and we can't count that out, but we know how much mass that is. So instead of going in there and counting the atoms, we're going to go in there and weigh the mass. So how many hydrogens do we have? 2. So my molar mass of hydrogen peroxide, which I like to shorthand as MM, is going to equal 2 hydrogens plus how many oxygens? 2 oxygens. Look up their masses on the periodic table. The mass of hydrogen is 1.01. The mass of oxygen is 16. I do the math, and I should get an answer of 34.02. What's my unit going to be? Grams per mole. This is molar mass, which means that if I have 1 mole, it's going to have a mass of 34.02. Honestly, what we're doing right now is we are making our conversion factor. So I can, now that I have my molar mass, I can now write a conversion factor. If I have 1 mole of H2O2, I should have 34.02 grams. I just made my conversion factor, didn't I? Okay, both sides of those are going to be equal to 1. They just have a different unit. So yesterday we got to use the same conversion factor for everything, right? Do we get to use the same conversion factor today? No, we have to refine this number depending on the molecule. Every molecule has a different ratio, which means it's going to have a different molar mass. And yay, we got the right answer. All right, so let's do a little bit more practice with molar mass. This one is asking us to find the molar mass of PCl3. So again, molar mass, I do capital M, capital M. How many P's do I have? 1. How many Cl's do I have? Okay, if I look at the periodic table, the mass of my phosphorus is 30.97. And then I need 3 chlorines, and the mass of my chlorine is 35.45. So if we put this in our calculator, we should get and I don't have enough room, so we're going to write it down here. 137.32 grams per mole. What did I just create here? A conversion factor. So have I even got to the converting step yet? No, I'm just showing you how to write your conversion factors. So let's do the second one now. Okay, the second bullet point is saying what is the mass of 1 mole of sodium hydrogen carbonate. So basically it's asking you to find the molar mass, right? Because the molar mass is how much 1 mole weighs. So sodium hydrogen carbonate, which, side note, this is the same things we used in the lab last week, the white powder that you guys decomposed in the chemical reaction lab. That's what we're talking about here. So to find my molar mass, how many sodiums do I have? 1. How many hydrogens do I have? How many carbons do I have? 1. How many oxygens do I have? All right. So then I look up the values on the periodic table. Sodium is 22.99. Hydrogen is 1.01. Carbon is 12.01. And then we have 3 oxygens, which is 16. Okay. Again, I'm going to plug all this in my calculator, right? So 22.99 plus 1.01 plus 12.01 plus... we get 84.01 grams per mole, right? Again, what did I just create? My conversion factor. All right, so do you think we're going to continue to just do conversion factors? No. We have to make the conversion factor before we can do the converting. So now we need to practice doing the conversion. So let's say we don't need 1 mole. Let's say that we need 3 moles of sodium chloride for a laboratory experiment. So for instance, let's say each one of you need a mole of sodium chloride, but there's going to be 10 groups. I'm going to have to make more than just 1 mole, right? I would have to make 10 moles. So the same basic concept. But I can't go in the lab and put sodium chloride on a scale and it's going to tell me when I get to 3 moles. The only thing that scale is going to tell me is its mass, right? So I then have to do a little bit of converting to figure out how much mass I need. So, first off, we have to find the molar mass because we can't do any converting without the molar mass, right? So, the molar mass, how many sodiums do I have? 1. How many chlorines do I have? 1. So, 22.99 plus 35.45. Where did I get those numbers again? They're the masses listed on the periodic table, right? Okay. Add them together. So 22.99 plus 35.45. And I get 58.45 grams per mole. What did I make here again? My conversion factor. So 1 mole of sodium chloride is going to be equal to 58.45 grams. Now I can use that in step number 2 when I do a mole conversion. Okay, what is the first step in any conversion? You write down what you are converting. So we look back at our problem. The problem's asking us to convert 3 moles, right? So first step, 3 moles. Until we get good at this, we're going to write down where we're going. So where are we going? Mass, which is grams, right? If at all else fails, it keeps you from writing anything underneath that. Then I need a conversion factor. We're going to put what we want over what we have. So what unit do we want? We want grams. So then I'm going to use this side of my conversion factor. What unit are we currently in? Moles. So I'm going to use the left side of my conversion factor. This unit cancels out that unit. We are left with grams, which is what we were wanting, correct? So then we are going to do 58.45 times 3, and we get 175.35. Am I done yet? No, why am I not done yet? Significant figures. How many significant figures did I start with? 3. How many do I get to end with? 3. So I need to round 175. Do I round it up or leave it the same? So my answer is 175 grams. And if you want to throw in sodium chloride, that's fine, but the only one that you have to put it on is when you're doing moles. Girls. All right, so let's try to do one all from start to finish without any help. Okay, so this is number 7, and again, these will be on your homework quiz, right? You'll have 12, and then you'll have a few more next week that'll be on your homework quiz. All right, so number 7 says, calculate the mass in grams of 3.42 moles of copper 1 carbonate. So first of all, when you see the words grams and moles in the same sentence, flashing lights should be going off in your head, and you should be thinking, I need to find my molar mass before I can do anything. Okay? Whenever you see those two things together, molar mass. And then I read and I go, copper 1 carbonate. Mrs. Tackett is so mean. She expects me to be able to make an ionic compound at this point in time. We had a test over that before Christmas, right? But we still need to be able to do it. So what is this 1 right here telling me? A charge of copper is 1 positive. So we have copper, 1 positive. Carbonate, one of those pesky polyatomic ions I still don't have memorized. What is it? CO3. Whew. 2 negative. Why is it a good idea to always put parentheses around my polyatomic ions? So that when you have to change the ratios, you know what has to stay together. So is this neutral right now? No, I need 2 coppers to every 1 carbonate, right? Now can I find the molar mass?
Yes.
Yes. So my molar mass is going to equal 2 coppers plus how many carbons? Plus how many oxygens? Okay, so 2. Copper has a mass of 63.55 plus carbon, which is 12.01, plus 3 oxygens, which is 16. So if I put all that in my calculator, we get 187.11 grams per mole. What did I just create? My conversion factor. So 1 mole of Cu2CO3 is going to equal 187.11 grams, right? So now can I start my conversion process? Yep. All right, what's the first step in every single conversion process? Write down what we're converting. What are we converting? We are converting 3.42 moles of my copper carbonate. And then until we get good at this, we're going to write down where we're going. Where are we going? To grams. Then I need a conversion factor. I put the unit I want over the unit I have. What unit do I want? Grams. So I'm going to use the right side of my conversion factor. So 187.11 grams. What unit do I have? Moles. So I'm going to use the left side. So 1 mole of copper to carbonate. And then all I have to do is put this in my calculator, right? So 3.42 times 187.11. And we get 639.9162. Is that going to work? No. How many sig figs do I have to start off with? How many do I get to keep? So what is my rounded answer going to be? 640. Uh-oh. That doesn't have 3 significant figures. That only has 2. How do I fix that problem? I need to not point 0. I just need to put a decimal. Now, I know that that sounds silly to throw in a decimal there. What difference could that possibly make? But it makes a huge difference, right? That's telling me that my rounded answer is 640. Exactly. If I didn't put the decimal there, I'd be telling you my answer was 635 to 644. Somewhere in that range. And that's not the case, right? It was 640. So that's the importance of that decimal. All right. Last but not least, I need to put my unit. What's my unit? Grams. And again, you don't have to, but I usually do. Throw in the compound. Oh, you only have to put it with moles. Okay. All right. So let's give number 8 a shot. All right. Number 8 says, calculate the number of moles in 53.6 grams of dinitrogen trioxide. Again, as soon as you see moles and grams in the same sentence, something's going off in your mind. Molar mass. I need to find the molar mass. Okay. What? This is a covalent compound. Mrs. Tackett expects me to remember this. How in the world am I supposed to remember the prefixes di and tri? Are they possibly posted somewhere in the classroom? Tara, can you be Vanna for me back there? Right there. So what is the prefix di? 2. What is the prefix tri? 3. So what is my chemical formula here? N2O3. So now I need to find my molar mass, right? How many nitrogens do I have? 2. How many oxygens do I have? 3. So then I just plug in their masses from the periodic table. So 2 times 14.01 plus 3 times 16 is going to give me 76.02 grams per mole. What did I just create here? My conversion factor. 1 mole of N2O3 is going to be equal to 76.02 grams, right? So now I get to start my converting process. Do you guys see how these today are a little bit more lengthier than the ones previous? Okay. So let's do our conversion. What's the first step in every single conversion? Write down what we're converting. What are we converting? So 53.6 grams. Until we get good at this, I want you to write where we're going. So where are we going? Moles. Okay. I need to put what I want over what I have. What unit do I want? Moles. So I'm going to use the left side of my conversion factor. 1 mole of N2O3. What unit do I have? Grams. So I'm going to use the right side of my conversion factor. 76.02. That grams cancel out that grams. We are left with moles, which is what we wanted. So now we just plug it in the calculator. Divide 53.6 divided by 76.02, and we get 0.70507 ... How many significant figures do I get to keep? 3. I started with 3. I get to end with 3. So what's my answer going to be? 0.705 unit moles of N2O3. You only have to put the unit with the moles. So you can't just say moles. You have to say moles of something. Okay? Now, can we do some of this in our head? Yes. Why do you think I'm being so particular about wanting you to learn how to write conversion factors? Do you think we're going to continue to have one-step conversions? No. Do you think we're going to continue to have 1 on the numerator or 1 in the denominator? No. So if I teach you guys the process with easier calculations, I'm hoping that you'll learn the process so that when we get to harder calculations, the foundation's already there. So, on a test, how many points do you think this would be worth? Okay, well, 1 point for knowing where to start, 1 point for getting the correct conversion factor, 1 point for an answer with our unit, and oh yeah, you had to find your molar mass earlier, right? So technically, this problem would be worth 4 points, noticing the least emphasis is placed on the right answer. Technically, you could get half a point just by putting the correct unit, right? Yeah. All right, so your homework, you have 4 practice problems and you have 15-ish minutes in class to do it. I want these done in your notebook. Just continue the numbering. Again, they'll be on your homework quiz next week, which right now I'm thinking is going to be on Wednesday. Okay? 9 through 12 is your homework.